two-dimensional motion. This is the paper we're going to be using. Cut out dotted lines only. Cut out dotted lines only. When you're ready, with it all cut out, go ahead, pause if you need to, get that cut out, and let's get started. All right, so far in my class, you have learned about linear motion. Linear motion. Okay, so linear motion, I've taught you about quite a few things, giving you quite a bit of vocabulary to work with. Okay, so we have done distance and displacement. Okay, there's terms you've learned. You've also learned the terms of speed and velocity. You've learned the term at rest. And you've learned about acceleration versus deceleration. Okay, all of these terms you've taught, I've taught you. You've learned them, hopefully you understand them, okay? Now, all the little pictures you cut out, okay, looking through all your little pictures there, which one do you think is the most appropriate to demonstrate linear motion? Ta-da! The speedster in the car, okay? I've also taught you another form of motion. Look through all your little label cards, your little label. Which other motion have I taught you? Which other one have I taught you? I have also taught you projectile motion. Go ahead and glue in right there below, projectile motion. Okay? Words, terminology, things you've learned about projectile motion. You have learned about apex. You have learned about range, also known as horizontal displacement. You have learned about projectile, the object flying through the air. You have learned about trajectory, the path that the object travels through the air. Okay? You've also learned about vertical displacement. And vertical versus horizontal velocity. You've learned about all of these. Okay? Vertical versus horizontal velocities. Okay? All right, go through your pictures and find a picture that represents projectile motion. Can you figure out which one it is? Projectile motion. There we go. Glue it in. There's your picture that demonstrates projectile motion. That's what I've taught you so far. Okay, so let's look at the cards that are left. Okay, we've got a picture of a duck on a, there we go, we got a little train going around on a circular track. We got a girl swinging back on a fourth in a swing. And we've got a top spinning around. We got 4 more descriptions left. So let's see if you can match those descriptions. Okay, which of these, okay, probably the easiest one, wave motion, that's your little duck on a wave. Okay, circular motion, that's your train going in a circle. Okay, rotational, that's your top spinning around. And harmonic is the girl swinging back and forth in the swing. We are going to talk about these two very briefly, rotational and circular, because that is more of an AP physics topic, but we're going to briefly discuss it, actually in this journal entry. And then wave motion, harmonic motion, we're going to get to that about like 5 weeks-ish, and go through a lot of detail on those. Okay, so let's start gluing in, just to like glue it in there for visual. Let's do our harmonic and wave. And actually, harmonic motion and wave motion are very similar. Okay? They're very, they might not appear to be that way, but they are. Okay, so we've got harmonic motion. I will actually teach that one to you. It will precede your understanding of wave motion. Now the reason this journal entry is called two-dimensional motion is because I've taught you linear motion, okay? And projectile motion, everything after linear motion is all two-dimensional motions, okay? So we start off with linear motion and we're progressing into a variety of two-dimensional motions. Over here on our OOPS page, don't turn the page, just right here on the OOPS page, we are going to glue in at the top circular motion in your little train, rotational motion, and your top. Let's go ahead and get those glued in. So circular motion, rotational motion, very, very similar things. Many things you can use to describe them, we describe similarly. They are technically different, but they do a lot in the same. One of the concepts that goes with it is centripetal acceleration, okay? So centripetal acceleration, it more commonly refers to circular motion, but under certain circumstances we can apply it to rotational motion. Okay? Centripetal acceleration. So the acceleration of spinning objects, so to speak. It says the rate of change of direction of an object. Objects moving in circles have a constantly changing direction, even though the velocity of the object does not change. We call that object the tangential velocity. Okay? The angle is changing at a constant rate. So to clarify and understand this just a little bit better, let's remember back to velocity. There are two components to velocity because it is a vector measurement, okay? It has both speed, which is how fast it's going, the magnitude, and it has direction. And so far I have taught you that acceleration means that the object's speed is changing, okay? But that's not completely correct. Acceleration means that the velocity is changing. Okay? So I taught you it's either speeding up, it's going faster and faster and faster and faster, or it's slowing down, it's going slower and slower and slower and slower. But that is true, but that's not the full truth. Everything I've taught you so far is about how the speed changes to get acceleration. But we can also have a change in direction. And if the direction changes, it's also accelerating. So acceleration either means the speed's changing or the direction is changing, or... Okay, tangential velocity. I have here my keys hanging on a lanyard, and I spin it around. It's moving in a circular motion, okay? And if you look at it, you can see that it has a steadiness about it. It takes the same amount of time for it to go all the way around that circle. That has a constant tangential velocity. The velocity is kind of like if you could put a speedometer on those keys, okay? How fast they're going, it would have a specific speed that wouldn't change. The speedometer would kind of be stuck, okay? So a constant tangential velocity is what we're looking at here. The angle moves at a constant speed. Now, we take that for centripetal acceleration, we need to know the radius, what that tangential velocity is, and plug it into the formula. Now, remember, acceleration, it can be either a changing velocity or it can be changing direction. Here we have a situation of a constant velocity, a constant tangential velocity, but the direction is constantly changing. So, let me explain. As this is spinning around, okay, in its circle. At this moment right here, when my keys are right here, they are moving that direction. When my keys are right here, they're moving that direction. When they're over here, they're moving this direction. So that direction is constantly changing. Because it has a constantly changing direction, it is accelerating. And there are forces involved in that, and we'll get to that when we talk about Newton's laws of motion. The forces that are involved with acceleration, that has forces involved that keep it going in a circular path.